whenever the Cartesian equation of a straight line is given, you should always observe that whether this is in the standard form of x minus x1 by a, y minus y1 by b, and z minus z1 by c. Skew lines are the line which are not coplanar. So we know that coplanar means all the lying on the same plane. The distance between them is always the perpendicular line which is perpendicular to both the lines. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. Here in this session, we are going to learn about the angle between the two lines and the shortest between the skew lines. Now, in our previous session, we have learned how to represent the equation of a line when it is passing through a given point as well as when it is parallel to some vector to the given vector. So, we know the Cartesian as well as the vector form of the line. So, here angle between two lines, let L1 and L2 be the two lines passing through the origin and with the direction ratios A1, B1, C1 and A2, B2, C2 respectively. Then the angle theta between them is given by cos theta is equal to modulus of A1, A2 plus B1, B2 plus C1, C2 divided by A1 square plus B1 square plus C1 square under the square root, A2 square plus B2 square plus C2 square under the square root. If suppose we consider L1 is parallel to some vector B1 and L2 is parallel to some vector B2. So, whose direction ratios of B1 is A1i plus B1j plus C1k and direction ratios of B2i is equal to A2i plus B2j plus C2k. Then the angle between these lines which is parallel to the given vectors is given by the dot product of B1 and B2, that is A1 A2 plus B1 B2 plus C1 C2 divided by magnitude of B1 and magnitude of B2. This can also be represented in the form of vector B1 dot vector B2 whole divided by magnitude of vector B1 and magnitude of vector B2. So this is the Cartesian form of the angle cos theta and this is given in the vector form. So, simple way we can say it is a dot product of vector B1 and B2 by their respective magnitudes. Now, we have some observations here. So, if two lines with the direction ratios A1, B1, C1 and A2, B2, C2 respectively and they are perpendicular to each other. If they are perpendicular to each other, that means their dot product has to be 0. That means the dot product of B1 and B2 must be 0 if they are perpendicular to each other. And if the direction ratios are in proportion, that is vector B1 is A1, B1, C1, vector B2 is A2, B2, C2. If you take the proportion of their respective scalar component, it has to be equal to the common element, some k. So, this should be equal to some constant k. So, then we say the two lines are parallel to each other. Hence, if cos theta is 0, we can clearly say the two lines are perpendicular. If the direction ratios are in proportion, we can say they are parallel to each other. Now let's take a problem. Show that the lines x minus 5 by 7, y plus 2 by minus 5, z by 1 and x by 1, y by 2, z by 3 are perpendicular to each other. Whenever the Cartesian equation of a straight line is given, you should always observe that whether this is in the standard form of x minus x1 by a, y minus y1 by b and z minus z1 by c. Because sometimes instead of x they might give you 2x, but in the standard form it has to be in the form of x minus x1 by a. Now clearly both the lines are in the standard forms. Now the point where the line passes is represented by these values. So here it is 0. And which is parallel to the given vector is represented by the denominator, that is the direction ratios of vector B1 and this is the direction ratios of vector B2. Now to find the angle between the two lines, it is always the dot product of B1 dot B2 respective of their magnitudes in the denominator. Now if we take B1 dot B2, 7 ones are 7, minus 5 into 2 minus 10, 1 3s are 3. whole divided by their magnitude, whatever it is. 7 minus 10 is minus 3, minus 3 plus 3 is 0. So here it is magnitude of B1 and magnitude of B2. So clearly we have cos theta is equal to 0. If cos theta is equal to 0, then theta is cos inverse of 0. So theta is equal to pi by 2. Since theta is equal to pi by 2, we can clearly conclude that the lines are perpendicular to each other. Next. Find the angle between the pair of lines x by 2, y by 2, z by 1 and x minus 5 by 4, y minus 2 by 1, z minus 3 by 8. So the cos theta is the dot product of these scalar components, that is 2 into 4, 8 plus 2 into 1, 2 plus 1 into 8, 8 whole divided by magnitude of vector B1, magnitude of vector B2, that is square root of 2 square plus 2 square plus 1 square, and here it is square root of 4 square plus 1 square plus 8 square. Now the numerator is 8 plus 2, 18 whole divided by, so this is root 9 and here it is root 81. So clearly it is 18 by square root of 9 is 3, square root of 81 is 9, 9 ones are 9 twos are, so 2 by 3. So cos theta is 2 by 3, so theta is equal to cos inverse of 2 by 3. Next question. Find the angle between the pair of lines given by vector r is equal to 3i plus 2j minus 4k plus lambda I plus 2j minus 2k and vector r is equal to 5i minus 2j plus mu into 3i plus 2j plus 6k. So we know that vector r is always represented in the form of a vector as a plus lambda b. So clearly this is a line which is parallel to this vector b1. And r is a line which is parallel to the vector b2. To find cos theta, we know that it is the dot product of b1 and b2. So let's take the dot product of b1 and b2. 1 into 3, 3 plus 2 into 2, 4 plus minus 2 into 6, minus 12. Whole divided by square root of the components 1 square plus 2 square plus minus 2 whole square. Again square root of 3 square plus 2 square plus 6 square. So here it is 3 plus 4, 7, 7 minus 12. So which is minus 5 divided by, so we can also take the modulus here to make cos theta as positive. So here it is root 9 and here we have root 49. So now cos theta is equal to, so 5 divided by root 9 is 3 into root 49 is 7. So which is 5 by 21 or theta is equal to cos inverse of 5 divided by 21. The next is we have the shortest distance between the two lines. So skew lines. So what are skew lines? Skew lines are the line which are not coplanar. So we know that coplanar means all the lying on the same plane. But here skew lines are nothing but the lines which lie on the different planes. So when the lines lie on the different planes, how to calculate the distance among them? In a space, there are lines which are neither intersecting nor parallel. In fact, such pair of lines are non-coplanar and called skew lines. Or we can also say a pair of non-coplanar lines which are neither parallel nor intersecting are known as skew lines. Now, to calculate the distance between skew lines, let us assume two lines. So, let I consider this as line L1 which is lying on another plane and L2 which is lying again with the different plane. Now to find the shortest distance between the two lines, it is always the perpendicular line between those two lines which is perpendicular to both the lines. So the distance between them is always the perpendicular line which is perpendicular to both the lines. Now here let us consider line L1 whose vector form is given by a1 plus lambda b1 and another line is given by a2 plus mu b2. Then If L1 and L2 be the two skew lines with the equation, then the required shortest distance between them is given by B1 cross B2 by magnitude of B1 cross B2 into A2 minus A1. So, if you learn this formula, it's easy to find the difference between A2 and A minus 1 vector. Then we need to take the cross product of B1 and B2 divided by its magnitude, so that the entire thing you will get in the form of a scalar quantity. Thus, the distance between the skew line is always the shortest distance between the perpendicular line to both the lines. Now, let's calculate the shortest distance between these skew lines here. So, here the vector form of the equations are given. Find the shortest distance between the lines L1 and L2 whose vector equations are I plus j plus lambda into 2i minus j plus k. R is equal to 2i plus j minus k plus mu into 3i minus 5j plus 2k. So, let this be vector A1 and let this be vector B1. This is vector A2 and this is vector B2. According to the formula, we need to first find what is A2 minus A1. Then we need to take the cross product of B1 and B2 along with their magnitude. Let's find vector A2 minus vector A1. So, we have here 2i minus I is I, j minus j is 0, minus, next we have minus k minus 0 which represents minus k. So, A2 minus A1 is I minus k. Let's take the cross product of vector B1 and vector B2. To write the cross product, first row we always write the components I, j, k. To the second row we will write the scalar components of B1, that is 2, minus 1, 1. And third row we will write the components of B2, that is 3, minus 5 and 2. So, let us expand this. We have I into minus 2 minus of minus 5 plus 5 minus j, here we have 2 2s are 4 minus 3 plus k into 2 into minus 5 minus 10 minus 3 into minus 1 plus 3. So, now B1 cross B2 is 3i minus j minus 7k. Now, let's take the magnitude of B1 cross B2. So, this is 3 square plus minus 1 whole square plus minus 7 whole square under the square root. So, 9, 10, 49 which is equal to root 59. Now, we know the formula that distance D is equal to vector B1 cross B2 dot A2 minus A1 whole divided by magnitude of B1 cross B2. Now, D is equal to, we need to take the dot product of B1 cross B2 as well as A2 minus A1. So, let's take the cross product. Okay. So, let's find the dot product. 3 into 1 because we have I component, 3 into 1, 3 plus next j component, there is no j component in A2 minus A1. So, it minus 1 into 0, it is 0. Next we have k component minus 7 into minus 1 which becomes plus 7. So, therefore, it is 0 plus 7 whole divided by root 59 under the square root. So, D is equal to 10 divided by root 59 units. So, this is the distance between the given lines. Next, find the shortest distance between the line x plus 1 by 7, y plus 1 by minus 6, z plus 1 by 1 and x minus 3 by 1 equals y minus 5 by minus 2 equals z minus 7 by 1. So, clearly by looking at the equation, the second equation is in the standard form. This is in the form of x minus x1 by a. But here we have plus in the first equation. First, let us reduce this into the standard equation. Then I can write this as x minus minus 1 by 7, y minus minus 1 by 7, z minus minus 1 by 1. Now, we know that The points represent vector A1 and below it represents vector B. So here vector A1 is minus I, minus j, minus k, and vector A2 is 3i plus 5j plus 7k. Similarly, vector B1 is 7i minus 6j plus 1k, and vector B2 is I minus 2j plus k. Now let's find A2 minus A1. So A2 minus A1 is 3i minus of minus I becomes 4i. 5j minus of minus j, 6j. 7 minus of minus becomes 8k. Now let's take B1 cross B2, vector B1 cross B2. I, j, k. Then 7 minus 6, 1. Then 1 minus 2, 1. So let us expand this. So if you expand this, I into minus 6 into 1, minus 6, minus 2 into 1, which becomes minus plus 2. Then we have minus j. For minus j, we have 7 ones are 7, minus 1. So 7 minus 1. Plus k into 14 plus 6, minus 14 plus 6. So we will get the value as minus 4i, minus 6j, and minus 8k. So now we have A2 minus A1 as 4i plus 6j plus 8k, B1 cross B2 as minus 4i minus 6j minus 8k. Now let's take the cross product of these two, that is B1 cross B2 dot A2 minus A1, since we need this in the formula. So B1 cross B2 dot A2 minus A1, that is 4 into minus 4 plus 6 into minus 6 plus 8 into minus 8. So 4 into minus 4, 6 into minus 6 plus 8 into minus 8. So which is minus 16, minus 36, minus 64. So that is equal to 116. Now distance is given by B1 cross B2 dot A2 minus A1 whole divided by magnitude of B1 cross B2. Now we need to find magnitude of B1 cross B2. So magnitude of B1 cross B2 is given by square root of minus 4 whole square, minus 6 whole square plus minus 8 whole square. That will be equal to root 116. Now here if we substitute, D is equal to 116 divided by root 116 under the modulus. So it is minus. So to remove minus, we'll put modulus. So the answer is root 116 units. So this is the distance between the given equation of lines. The next thing is, we are going to find out the distance between the parallel lines. So we know that when two lines are parallel to the same vector, obviously vector B will be same. So here obviously there is no B1 and B2 separately because B1 and B2 are same. If line L1 is parallel to vector B2 and if they are parallel to L2, the line L2 also, then it is obviously parallel to the vector B1 itself. So there is no need to find out the separate vectors for the parallel line. Hence, here the distance formula for parallel line is reduced to vector B cross A2 minus A1 divided by magnitude of vector B. So in the previous formula, we'll take the dot product of B2 minus B1. Okay. We take the dot product of B1, B2 with A2 minus A1. But here we are going to take the cross product of vector B with A2 minus A1 divided by the magnitude of vector B. So let's take an example of a parallel line here. You can clearly see vector B is same for both the lines. But point A is different. Now find the distance between the line. R is equal to I plus 2j minus 4k plus lambda 2i plus 3j plus 6k. R is equal to 3i plus 3j minus 5k plus mu into 2i plus 3j plus 6k. So here this is vector A1 and this is vector A2. So these both represents vector B. Now since the two lines are parallel to the common vector, the formula is given by D is equal to B cross A2 minus A1 whole divided by magnitude of B. Now first let us find out what is A2 minus A1. So A2 minus A1 is 3 minus I, 2I, 3 minus 2j minus plus j. Next minus 5 plus 4 minus k. Then we will take the magnitude of vector B. Magnitude of vector B is 2 square plus 3 square plus 6 square under the square root. So that is 36 plus 4, 40, 49, root 49 is equal to 7. Now let's find the cross product of vector B and A2 minus A1. So B cross A2 minus A1 is represented in the form of the determinant as I, j, k. Now scalar components of vector B is 2, 3, 6. A2 minus A1 is 2, 1, minus 1. Let us expand this. So we have here I into minus 3 minus 6 minus j into minus 2 minus 12 plus k into 2 minus 6. So this is equal to minus 9i minus into minus plus 14j and here we have minus 4k. Now we have B cross A2 minus A1. Now we need to take the magnitude of B cross A2 minus A1 because B cross A2 minus A1 is a vector. So we need the magnitude of this. So which is minus 9 whole square plus 14 square plus minus 4 whole square under the square root. So this is equal to square root of 293. Now the distance is given by magnitude of B cross A2 minus A1 whole divided by magnitude of B. So this is square root of 293 divided by 7. So this is all about the chapter 3-dimensional geometry. Here we have a very important derivations of finding the equation of a line when it is passing through the given point and parallel to some vector B. Along with that, you might have a problems with angle between the lines as well as the shortest distance between the skew lines as well as parallel lines. I'll meet you in the next session with the new chapter. Until then, keep watching, keep learning and keep exploring. Thank you.